Not a real thing. Not a real thing. Okay.
Oh, that's good. What's not a real thing with so many people? You were
You getting math tattoos.
If I were to get any tattoos, they would probably be math themed.
Okay. So basically, what I'm going to go through today shouldn't be anything alarmingly new. It's more about some refreshers on some identities, as well as just some strategies when we have sine and cosine together in an integral, or secant and tangent together in an integral, or cosine or sine raised to a power by itself in an integral. Okay, and what we can do. So let me remind you of, first of all, this first one is what we call the Pythagorean identity. Yes? Yes, sorry. Did it say that over here? It didn't. That was my bad.
It does on the board though.
Oh.
I'm sorry.
Today is a crazy day.
Wednesdays are just weird.
Wednesdays are like mine.
I have more time in the morning because I wake up at the same time, but I don't leave until 20 minutes after bedtime. So I make my bed.
Okay, can this be rearranged?
Yes.
Okay, you know it as sine squared plus cosine squared equals 1. We can rearrange it like you have. Okay. These two are what we call power reducing formulas. You may have seen them in pre-calculus and then didn't remember them, and that is fine. I think these were ones that we wrote for you on your test if you needed to reference them.
Will you be doing that again?
I will not.
Gosh darn it.
Good try, Darby.
What about on the first quiz and then we're on our own for the test?
I think you're going to use it enough to where you don't need to. Okay? But let's look at them. Sine squared and cosine squared. Do they look very similar?
Yes. Yeah.
They're both involving cosine of 2x. One's plus, one's minus. That's the only difference. Okay? Let's talk about what happens. Whatever your angle is here, when you reduce the power, it gets doubled. Okay? So if this is 5x, and you use the power reducing formula, your new angle would be 10x. Okay?
How do you get from there to there?
That's a big old nasty proof thing.
Like algebraically?
Yeah.
You have to use the
I would have to draw a unit circle and draw a bunch of angles, and it wouldn't be very enjoyable.
Angles?
And angles.
Oh.
Okay, so I don't want you to write this down. This is too much. But basically what you need to look for, if there is a sine and a cosine raised to a power in your integral, you need to look for whoever is odd. So I like to call him the odd man out. Okay? Who has an odd power? Why would that be helpful? Okay? Well, if sine has an odd power, then we can break it up. We can make it sine squared, sine to the fourth, sine to the sixth, whatever even number with a sign left over that we can use for u substitution. Okay? If we make u equal cosine, we have our sine du. Okay? And any sine squared, we can change to 1 minus cosine squared. Okay? So whoever's the odd man out, we're going to save 1 for our du and then change the rest to look the same. Okay? So if cosine was odd, we'd save 1 cosine, change all of the cosine squareds to 1 minus sine squared, and then we've made a u substitution that is nice. Okay, yes.
I do have a dumb question. What happens to that like plus one? Like it goes from like sine 2k plus 1 to sine squared x. Okay.
Okay, so he comes right here. So we break it apart. Okay, sine to the 2k times sine to the first. We combine them, sine to the 2k plus 1. So essentially the odd, we pull them out. We take the evens and we change them with the Pythagorean identity. And now we have u substitution. Okay, here's the deal though. Like if this is sine squared, like let's say we have sine to the 6th, right? That would be sine squared cubed. You would write it as 1 minus cosine squared cubed and then just stop. Okay? Don't try to go any further yet. We'll talk more about that in a moment. Now, what if you don't have an odd man out? Okay?
Then you have to choose one.
No, because then it wouldn't work out with the sine squared and cosine squared. Okay? We have to have at least one to be even. Well, no, we don't. I take that back. We have to have at least one to be odd if we're going to use this strategy right here. If they're both even or you just have one, you have to use the power reducing formula with sine squared and cosine squared. So we'll look at examples of each of those. Okay?
So we're just gonna use a whole lot of these identities that we wrote down.
Are these problems gonna be this height 6 or 7?
My work is right here for this one. Okay? When there's sines and cosines together, I told you to look for which kind of exponent? Odd. Who has the odd exponent?
Sine.
Sine. So since sine has the odd exponent, we are going to break it up into sine to the first times sine of whatever's left over, which should be even, right? We're breaking that apart so we can use u substitution. So you are going to leave, whichever's the odd one, you're leaving only that one lonely function alone, and then the one that is now even, you're going to change it using the Pythagorean identity. Why is that helpful? Now we can say that we want u to equal cosine of x, the one that wasn't odd, which makes du negative sine x dx. Well, look at this, ladies and gentlemen. We have sine of x dx. And everything else we can write as u's and du's. Okay? So what we can write is that we have the negative integral. Sine of x dx turns to du. And then we have 1 minus u squared times u to the 4th. Now we have something polynomial. It's nice. Should I integrate it right this second?
No.
No.
You should multiply the u's so you can get u to the 4th minus u to the 6th.
Okay. So I'm going to go ahead and be crazy here, and I'm going to write it as u to the 6th minus u to the 4th.
I see what you did there. Wow.
Because I don't want to deal with that negative on the outside.
Oh,
Are you following?
I'm following.
Okay. So we have 1/7 u to the 7th minus 1/5 u to the 5th plus c, and we know that u is cosine of x. I'm really cutting my cake. Yeah. Thank you. Okay. What do you think? Not so bad?
Not bad, yeah.
We're
Joe, maybe on
suspicious,
some-
we know it's gonna get worse.
As soon as we have to start doing the power reducing stuff, I'm losing it. It's not gonna do so. Oh, it's a new problem.
Okay. Take 1 minute, and at your table, don't write anything besides the problem, but talk about what your strategy would be to move forward in integrating this.
My strategy is to keep up with everybody by doing the problem while we all talk about it.
Hey, we must join us. Join the square. Okay. Okay. Okay, join the square.
It's like your leftovers, you stick it in the
Okay, so our strategy cosine is odd, so we're gonna pull a little cosine out of it. Yeah. It'll be sine course. Cosine.
I'm doing this like this actually really hurts my hands.
Yeah, cosine square.
My wrists.
That's not normally work. It's kind of like comfortable. Wait, who?
I guess
I'm like Hannah. She has one hand, so
All right.
okay, and break. Nice job, team 4. Team 4. It's a pod.
Pod 7. Pod 7. What are your thoughts?
I think you just take out cosine, and then at that point you can substitute 1 minus sine x squared x, and then square that. I think that's how that would work.
Okay, so we are going to rewrite it. We're going to take out a cosine. So cosine to the 4th times cosine. Right? And then, like let's really talk about why we did that. We needed a leftover for u substitution. So if cosine is our leftover, which one are we changing? Whichever one's odd is what we're changing. We kept one left over, and then we're going to change. So we would write 1 minus sine squared squared.
Ooh.
Ick, right? Not that bad.
I feel like it'll be a little.
When we change it to polynomials, it'll be a lot easier to look at. Okay? Alright. So we've done all that work so that we could let u equal the sine of x. And notice how it's just sine of x, it's not to a power. Du is cosine of x dx. We have cosine of x dx right there. So this becomes the integral of u to the 4th times 1 minus u squared, the quantity squared, du. Oh, can we square binomials with ease at this point in our mathematical careers?
At one
Not
point.
likely.
I mean, you could just, I would factor it in so you don't have to multiply u to the 4th by a trinomial.
Like that, Joe?
Oh, wouldn't it be u to the 4th minus u to the 6th squared, so then you would have plus u to the 12th, because u to the 6th times u to the 6th is...
Well, because this is going to give you 1 minus 2u squared plus u to the 4th.
Yeah.
And then when you multiply by u to the 4th, you add your exponents. You understand what I'm saying?
But u to the 4th times u minus u to the 6th squared would be equivalent, wouldn't it?
Hey, you're very smart. Yeah.
Because you can multiply u to the 4th getting u to the 4th.
No, because there's different powers. So u has a 4th power and 1 minus u squared has a square power. You can't combine them. Now you could view that as u squared squared and multiply u squared. So that would be fine. Okay. Does that that make sense what I'm saying?
Yeah.
Okay.
Yeah.
All right, so we have 1/5 sine to the 5th x minus 2/7 sine to the 7th x plus 1/9 sine to the 9th
Just wait,
x.
it'll get worse.
Are you okay with me just going to there? Because we know that you assign. Is that okay?
Would you ever believe that the integral of sine to the 4th x times cosine to the 5th x would be that?
No. No.
Now, give me a moment here, because I do want to warn you about a couple problems, and I need to reference.
Never integrate.
Oh,
My brain feels so big. I've been doing so much living lately, guys.
Okay,
It's
so
like nothing but like
there is a problem in your book. I just gotta find it.
we all better be wearing our shirts on Friday.
Oh yes. Oh yes.
If anybody doesn't wear their shirt, they're not coming, right?
Oh, obviously.
Okay,
I think I'm wearing my fun jacket again.
like there could be a problem. There could be a problem where maybe you have two odds. Okay,
Ooh.
which means
Double.
some of you
reduction.
may pick cosine, some of you may pick sine, which means your answers would look
We
different.
have options.
What?
When there's two odds, there's options. We can pick
Yes.
either. That's so
What that
exciting,
means-
Miss
But
Lynn.
but what I need you to understand is that like your answer may be in terms of sine, my answer may be in terms of cosine, but they would be equivalent based on all of our identities that
Yes,
we
and
would
then,
want to
then we're
go.
gonna have a problem on the test.
Okay.
It's like solid.
So I just want you to
That was pretty
understand it. Okay? All right.
Serious pickup flashbacks.
like PTSD.
And like rose cups.
I need to come up with like
We'll get back to this.
it's not
Oh.
PTSD. It's like okay, so PTSD stands for post.
Traumatic stress disorder.
PTCD, post-traumatic calculus disorder.
That would be more appropriate. All right, write this down.
But we're still having the calculus
Actually, that makes
stress.
perfect sense. Oh, it's
Yeah.
a definite interest.
This class isn't my biggest stress though, Miss Holman. I don't know if that makes you happy or sad, but it's not my biggest stress. Yes.
That would make sense. Okay, what is the issue we are dealing with here?
We don't have a little man to be our DU.
We don't have a little man to be. Okay, sure. We don't have like a sign left. We don't have a sign at all,
So,
which means we can't use U substitution, and we have cosine to the 4th power. Like you don't have an antiderivative for that.
so I'm
Uh.
assuming we're using the reduction thing.
Mhm. Yeah. So this is like cosine squared. Squared.
Yeah, I feel you. I'm with you.
And what is cosine squared the same as?
1 plus cosine of 2x over 2.
Okay. Well, that still doesn't like solve our problem. Let's go ahead and maybe carry out that operation.
Shouldn't that be pi to the over 2?
Yep, didn't read right. Okay. So if we carry out that operation, we would have 1/4 plus 1/2 cosine of 2x
Oh my gosh.
plus 1/4 cosine
Oh,
squared of
it's a
2x.
small and-
Oh my goodness. Oh my goodness. I see
Hey,
where we're going.
hey.
I love this.
I do too. Okay. That solves a portion of our problem.
Do we have to do it again?
Yeah.
Because
Don't
now,
finesse me.
because we have a cosine squared now, so we can put a sign in.
No.
Oh my goodness, that's just so
I
exciting.
knew this
Well,
was
No,
Okay.
We should just,
Since we have cosine to an even power with
We can
nothing
change
left
it.
over,
Oh,
we have to
don't
change it
cosine
again.
squared is
That's so exciting.
now,
Rhiannon.
but hold on. Would changing it to 1 minus sine squared be helpful?
no.
No. Yes. So don't get too excited, Derby.
Oh. Okay.
We're still going to change it, though, to 1 plus cosine of
4x.
over 2.
Did we do something like this before? Did we have to change it twice? I think I remember that from pre-cal.
Double, 12.
Okay. Now we have cosines that only have a power of 1. Now, if we had cosine to an odd power, that would be fine because we could leave out a cosine and change the other to 1 minus sine squared, and that would be beautiful. But when cosine is lonely to an even power, or when sine is lonely to an even power, we have to use our power reducing until we have lonely cosines. Okay? So can we rewrite this, please?
Yeah.
I don't.
Okay.
We can try.
All right. So do you agree that this is 1/4?
Yeah.
And then this would distribute to be 1/8?
Yeah.
Can we just do that? Like, I don't.
So it'll be 3/8?
Yeah, that sounds about right.
I'm the extra.
Why do I just want it to be pi over 4? It's pi over 2. It's pi over 2. Thank you.
How are you able to like separate them? Because this is an addition.
Well,
you're already
But
adding
this
them.
is like 1/2 plus 1/2 cosine of 4x, right?
Because there's only one guy in the denominator. So,
Yeah.
we can send him to the
Both
different parts
places.
of the numerator.
Mhm.
Because he's only one. He's only one.
And so are we okay with the 3/8?
Yeah,
How
we
do you get a
are.
negative?
And are we okay with 1/8 cosine of 4x?
Yes.
Yes.
Okay. So at this point, we can actually anti-derive. We can take 3/8 x. Please be careful. When we take the antiderivative of cosine, yes, we get sine. But since there's a 2x inside,
It's a 1/4.
we're going to have to multiply by the 1/2. So we have 1/4 sine of 2x. So over here would be
1/32. Let's see.
Wouldn't that be sine not cosine?
yeah.
Wouldn't it?
I just got so used to.
I got freaked out for a minute.
I did it.
No, I've been doing that at my homework. Well, I'll like rewrite it instead of anti-driving it, and I'll have to go back and look at it. And be like,
I've
what am
got
I
the
doing with this
answer.
life?
Sometimes when I'm doing my homework, I forget to put like if there's a 2x inside the cosine, I'll forget about it. Then I have to, so annoying.
It's not
Okay.
that bad.
You didn't write pi over 4 this time. I'm proud of you.
Thank you. So we have 3/8 times pi over 2 plus 1/4 times the sine of pi
0.
plus 1/32 times the sine of
2
2 pi
0.
Yeah, you did it.
minus
0
0, right?
plus 1/4 0.
When we plug 0 into all of those, they go to 0, right? Sine of
Yeah.
0, sine of 0, 3/8 times 0.
So 3 pi to the 16? Or 3 pi divided by 16?
3 pi 16.
That is
Magic tricks are happening.
magic tricks.
Yeah, it's like magic.
Math magic.
Yeah.
You're a mathematician.
That would be weird.
Not for nothing. Not for nothing.
Magic.
Yes, not for nothing.
And then
Them going to 0 makes it easy.
Yeah.
Okay.
Can I just go back to like around the world? Like,
plus
It's
C. No,
almost
it's definite.
I hated around the world.
Before we move to secants and
They
tangents,
make me do math in my head. I don't like that. My brains don't work.
I want to talk about a lonely odd. Okay? A lonely odd can be
A massive
approached the same way as an odd with an even.
Not of the friend.
Like we can change this to cosine squared times cosine. And we would still change to 1 minus sine squared x. Wow.
There's gonna be like one of each on our test, isn't there?
And so then you can use U substitution at this point, right? U can be sine, and then du would be cosine, and you have the integral of 1 minus u squared.
That's pretty.
To be honest, ladies and gentlemen, we just need to practice different kinds of problems, okay? The more problems you encounter, the more comfortable you're going to be, the more confident you will be on your quiz on
Wow.
Wednesday.
Okay, that's a hot minute. That's a hot minute.
I was at today's
Right, quiz. Is the quiz
Yeah,
next
you're right,
Wednesday?
Tuesday, you're right, Tuesday.
No, but it's a way back Wednesday
Yeah.
on the gold sheet.
Yeah, but I may have, like, misnamed it.
Oh.
Is the 23rd a Tuesday?
Most
What's
definitely
today? 7?
is. Yeah, because
What's
look,
17?
look.
Yeah.
Matt, this is Friday, Monday, Tuesday. I just wanted it to be way back Wednesday. Okay,
Take it back Tuesday.
so
Oh, there's more.
when we get into secants and tangents, things get a little bit iffy. Okay? And there's definitely. Sorry, we didn't finish that last problem. Is that okay?
What was the answer?
It's not okay?
No.
X
okay.
minus
It's not okay.
1/3 sine
Okay.
of x plus z.
Are
Okay.
we done? Like, are we done taking notes, or are we taking more over secant and tangent?
We're going to talk about secant and tangent. But I'll do this for you, Kaylee.
Kayla's speaking.
My brain hurts. Only more slides. Actually, 2. That doesn't change the fact that my brain hurts. I don't think that's.
Um,
What? Lily, do you have a problem?
you clearly-
Ah,
Lily, what's the problem?
there.
Wait,
Is that better?
Yeah, I was gonna say it is sin x, and I heard him say x, and I was like, that one would go with you.
why would the 1 become a u?
Because you're integrating with respect to.
Well, because the cosine.
Oh,
Yeah. Okay.
I think it does.
Okay. All right. So when we have secants and tangents, things get kind of strange because the derivative of secant is secant tangent, and the derivative tangent is secant squared.
So you need to do lots.
So if you are going to let u equal secant, you need to have a secant tangent left over.
So
If you are going to let u equal tangent, you need a secant squared left over.
Yes. Iconic. Sounds reasonable.
Okay? So I wouldn't say that we have like, you know, cosine and sine we have like are odd, right? This one, you're going to have to think.
Oh no.
It's scary, I know.
Yeah, I haven't done that in a few years.
So you're gonna need to ask yourself.
She does that every day in psychology. Yeah, she does.
the
Because
dolphin.
it's next to Madison in psychology, and we don't pay attention at all. That's true.
That's not good to hear. You're gonna have to think. Do I have a secant tangent I can leave out? Do I have a secant squared I can leave out? And that is gonna have to fuel your decision on what to let u equal.
What were those?
Okay.
Is that the equivalent of those mean work tone problems?
What?
Now, let's go ahead. Those of you who don't remember, we have another Pythagorean identity that could be useful in this case.
I have that written down.
It involves a 1 plus
secant squared x equals secant.
Tangent squared, secant squared, secant.
12.
Tangent.
this could be helpful to you.
Okay, I had it backwards, but it's fine.
Oh,
okay. Isn't it like 1 plus cotangent squared equals
I
cosecant
spelled
squared?
secant wrong.
Why are tangent and secant
Does anyone
related?
have a highlighter? Actually,
I do.
Okay.
But like, your hands are out.
What is that?
highlighter.
What time do we get out of here?
52.
It's substitute.
Are you tired of us?
No, that wasn't my comment. That was like, are we gonna have enough time? We keep getting.
She said
Distracted
that's what
by-
she was thinking, but really it was like, oh my gosh, get these kids out of here.
I look forward to my third
See,
hour
you'll look
every
forward
day.
to all day Friday. It'll just be like la 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 la
She's
la
not gonna
la,
be
la,
here
la,
Friday, you fool.
Right.
I'm gonna be with
She's
you
gonna be
all.
there.
Oh. That makes
Okay.
sense.
So here's the deal.
Very called you a fool.
If you have one that, like, if secant is even, okay, if secant is even, then you can change an even number to 1 plus tangent squared, and you can leave the secant squared for your UDU.
Well, what if it is secant?
Okay. So, like, for example, if you had secant to the 6th multiplied to tangent to the power, secant squared can say a secant squared, but then secant to the 4th, we could change to 1 plus tangent squared squared. Okay, and then we can use our U substitution. So if secant is even, that's a good sign. If secant is not even, you're going to have to look the other way.
Secant is the driver.
What?
Secant is the driver.
Okay, I'm not even on the struggle bus. I'm like desperately trying to hold on to the rear bumper. I got this.
Okay, so here's the deal. If secant is even, say the secant squared and change everything else.
Okay.
If secant is odd, say the secant tangent and change everything to secant.
Okay, so secant tangent is tangent. Or
Is secant is it is.
I'm not even trying.
Let's just watch her do it.
I don't want this 3. It's you. You. Oh, I see. Okay.
So these are the two things that you need to think about when you're doing your integral. Okay? Do I have, can I save something to let everything be in terms of secant, and then I have a secant tangent left over? Can I change everything to tangent where I have a secant squared left over? So in this case, yes.
Is this true for cotangent and cosecant?
Yes. 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 Because they have the same relationship, just with the negatives. Okay? So since we have an even here, we can easily write this as secant squared times secant squared. And change one of the secant squareds to 1 plus tangent squared. I don't get tired on that one. So now we have an opportunity to let u equal tangent. That secant squared is left over for our du.
The problem is that it would have to be a tangent of 3x.
It is,
So then it would be 3 secant squared 3.
which is fine.
You can just pop that 3 out to the outside.
Yeah.
You're right.
Just move her around.
So we have
Push her to
the
curve.
secant cubed 3x dx. Yes, we have that 3 multiplied out in front, but that's okay. We can even things out by writing 1/3 the integral of 1 plus u squared times u cubed du.
Mine was that like look so much nicer.
It just does.
I literally had a moment where I forgot how to derive / anti-derive secant and tangent.
It's like every Thursday.
Okay. So we have, ooh, that went a little bit further than I wanted it to. There, that looks good. So we have 1/3 times
1/4
1/4 was a tangent
to the fourth of 3x.
plus 1/6.
Tangent to the sixth.
Do it like that, I really missed it.
Oh,
Okay. Now, especially in the cases of tangent secant problems, like this one, we could have done the other way. Okay.
that's fancy.
I'll wait for everyone to have the answer written down, and then I'll scroll back up and tell you what we could have done. And if we would have done it the other way, our answer would not look like this. Okay? So I'm going to scroll back up. I think this is one you could.
It's like the twist.
Yeah.
It's like a choose your own adventure book.
Yeah. So what we could have done is we could have written this as secant cubed 3x tangent squared 3x times secant tangent.
I see.
And we could have changed tangent to secant squared 3x minus 1.
Oh,
I see.
So then our u would have been secant 3x. Our du, okay, we could have there. And then our answer would have been in terms of secant. And so it would look different than that. And that's okay, because we have properties to where that can happen. So I don't want you to freak out if you do a problem and your answer's in terms of tangent, but their answer's in terms of secant. That doesn't mean you're wrong. You just did it in a different way.
I'll try better have both.
You're right, but I'm not wrong.
I'll just figure out which one's bigger and do it that way.
Okay, CalcChat's not going to have both.
Why not?
That.
They're both
Because there's
viable.
You know what?
But
But Slater might have both.
Yeah.
Oh my gosh.
Does Calc have people getting paid? I know the tutors.
Okay, so you have 10 required problems.
I know the tutors.
You have 10
require
required
it.
problems and 4 that I did not require. So here's my advice. If you get through your 10 required problems and you feel iffy about one section, do the extra 2. Okay?
Oh my god.
What? Just him?
Yes. Just Gabe. Gabe is his own.
And I'm hangry and I have to go to sociology.
You don't
I
have to
would
go to
love
sociology.
sociology.